Neutrons or electrons? Electrons, the negatives, they also come from the number. So protons and electrons both come from the atomic number. Neutrons is the only issue you have to solve for. How do we solve for neutrons? What do we have to do?
Subtract the atomic number by the atomic mass.
Okay, so subtract. The atomic mass for lithium, let's look at lithium, is 6.9.
Yes.
So that rounds to what?
7.
7. 6.9 rounds to 7. And so then you subtract that 7 minus the atomic number 3. So 7 minus 3 is what? 4. So how many neutrons do we have? 4. How many protons do we have? 3 from the atomic number. So are there more neutrons than protons for lithium? Yes. If we did it to sodium, if we solve for neutrons, it would be the same. So this G says their atoms both have more neutrons than protons. So is that true? Is G true for the statement? For that, it's true, but is it answering the question of chemical properties?
No,
No.
it isn't.
So that is the difference of getting your answer. Both of these are true, but just having another neutron versus proton does not change the chemical property. Neutrons have no charge. They just contribute to the mass of the atom. That's it. And so it doesn't change the chemical property. It has nothing to do with chemical property. Since electrons deals with reactivity, which is a chemical property, a chemical characteristic. Does that make sense? And so be careful on some of these questions because you have to answer what it's asking. So it's kind of deciphering between that. H says their atoms have the same number of energy levels. Energy levels come from what?
The period.
Period number. Okay, period number. And so all elements in period 1 have one energy level. Right? One energy level where the electrons hang out. All elements in period 2 have how many energy levels? 2. So lithium's in period what? 2.
Who said 1?
Sodium's in period 3. So are they in the same period? No, they are not. And then J says their atoms contain equal numbers of protons and electrons. Each element has the same number of protons and electrons, positives and negatives. But if we're looking at two different elements, are they ever going to have the same number of protons and electrons? No, because they're different atomic numbers. So this question I wanted to go over just kind of all that because it's just a refresher, but also to show you these two would be right, but this one F are answered because the answer is in chemical properties. Okay?
Yes.
So what we're going to do today is a kind of cumulative review on the periodic table. So all you need out on your table right now is a pencil. I'll explain to you what we're going to do.
Well, we need Chromebooks.
No. You're welcome. All right, so what we're going to do is called
This is my third
brain
one.
dump on the periodic table. You are going to watch a video, and you are going to copy down everything that this person says in the video down on your paper. I will be pausing it. I'll be explaining stuff. I will tell you to add stuff, do stuff. You need to have your pencil in your hand this entire video with still copying the root. And write. Don't wait for me to pause it and then start writing. Right as you go so we can get through it, okay? We're going to do this side today, back side tomorrow. This is a grade. Tap, is this going to be grade? Yes. This is not going to be optional. If you fall asleep, guess what? When I check it tomorrow, you're getting a 0 for it. So it's not the most exciting thing, but it's something we need to do. So.
No, don't say that. She's going to make it hard.
Okay.
Put our name on it.
You can.
If you want.
Colton's not here.
Yeah, corner's been here for a while.
I was there.
We got some people.
Like 6, 7.
That was the most craziest thing ever. Don't ever show
I'm
me.
6'7".
All right, y'all follow along.
Vertically. Look horizontally.
Eighth grade STAR reference material hack. We want our students to do this. For every test, once they get the STAR test, we want them to pull out the periodic table and the formula chart and start writing all of the information that we provided in this video. This is a brain dump that will allow you to hack the STAR test. The first thing we're going to talk about is we want to make sure that periodic table. 8, which means that the atomic number equals the number of protons equals the number of electrons. Right up there by
8.
Number 2, we're going to point an arrow right at the atomic mass, and we're going to denote that that means protons plus neutrons.
Okay, so what he did, he drew an arrow to the 14, A equals P equals E for atomic number equals number of protons equals number of electrons. Next to the atomic mass, he drew an arrow and put P plus N, meaning protons plus neutrons give you your atomic mass.
Right on the periodic table. Number 3, we're going to talk about mass now, or excuse me, man now. So MAN is an acronym that means atomic mass minus the atomic number equals the neutrons. So you'll see the M in mass, and the A in atomic number, and the N in neutron all are an acronym for this little mini formula hack. Okay, you can even circle it, make it up. So if you're ever given a problem where you
Okay, so
Man.
what he did here, so under the printed where it says atomic mass, under that he put a subtraction sign and put atomic number with the line, and that gives us
Man.
neutrons. And what he circled was the M for mass, the A for atomic number, and the N for neutrons, and spelled M-A-N, man. So what that is just kind of a way for something kind of different, silly to remember. Man, how to combine
My
neutrons.
microphone on
Neutrons
me.
is the only thing that is not given to you, that you actually have to solve for. So, that's why we're writing that down. So, we gotta remember it's atomic mass minus
Could be
atomic
the
number
same too.
neutrons. What do you have to do
Phone.
to the atomic
Not
mass?
font. Phone.
Before you subtract it, you have to round it. So next to atomic mass, put the word round. Just as a little reminder, round, the word round.
So just put rands? I don't know how to. Huh?
Round, just the word round, next to atomic mass.
Can I get water?
to find neutrons. Well, you can talk about where the valence electrons are on the periodic table. How you can determine how many valence electrons each particular element has. So I'm going to write valence electrons up at the top. Then I'm going to draw some arrows to each of the groups and families. Just a couple of the groups. I'm not going to draw to each one of them. And I'll circle the group number or the part of the group number that represents the valence electrons. Notice that group 1 and 2 are also 1 valence electron and 2 valence electrons. But then we start working on groups 13 through 18, and we draw a couple arrows over maybe 13 and 18. And we have to drop the 1 off to make sure that we have the correct number of valence electrons. So for example, this one is group 13, but only 3 valence electrons. And then the next one will be group 14, but only 4 valence electrons. So everything in that group, in that family, will have the same number of valence electrons.
Okay, so you wrote the word valence electrons and drew arrows. He circled 1 and 2. Okay, just groups 3 through 12 follow the valence electron rule.
No.
They do not. Do you remember what that whole group is called? What type of metals are they? 3 through 12, this whole section is transition metals. Perfect. They don't follow the rule. You will not be asked a valence electron. You take away the 1, so you have 3 valence electrons. So that's why we circle the 3. Group 14 has how many? 4. Group 15 has 5, group 16 has 6, group 17 has 7, group 18 has 8. Next to the word valence electrons, put the word reactivity.
Ooh,
Valence electrons
my backpack
are
just
how
fall.
reactive they are. Put the word reactivity next to valence electrons. Reactivity.
Alright, now we're gonna move up to talking about groups or families of animals. So above, about 16, group 16. We're gonna write, these are called groups or families, and then I'm gonna circle this particular group. What this means is that everything in this group or family has similar properties and similar reactivity. So I'm going to also put a box around 16 to show that that's the group number. And I want you to confuse the group number with the valence electron number. This is actually the full number. So in this particular case, oxygen, sulfur, and so forth, selenium, tellurium, they're all going to be have similar reactivity. All right, moving on, we're going to now go over to the rows, which are called periods on the periodic table. Make sure we have reactivity on it, because that's what that group number tells us.
Okay, so for 16, you put a circle around 16, boxed out the actual number 16. Above that, you put groups or families. Remember, groups and family mean the same thing. Most of the time, you're going to see the term group, but sometimes you might see the word family. So that's why we wrote both. And then under that, you put similar properties and reactivity. This is what our warm-up question was about, right? So that elements in the same group have same chemical properties, and that leads us to reactivity. So it shows you, I want you to see how, like, you know, the stuff that we're doing is for a purpose, because it's how you're going to be seeing this stuff in real life. And so I just want you to be prepared. And so when we write this stuff down, it's stuff you're going to have to utilize and actually know.
And so now we're going to move over to the periods. And these are the rows. These are the horizontal rows going across the periodic table. And they tell us a couple of different things. They tell us the number of energy levels, and they tell us the number of energy shells in the actual core bond. So I was going to label periods across the side here. I'll put in parentheses energy levels and energy shells. You'll be real surprised how many questions will pop up on this STAR test that will be able to be answered by.
Okay, so throw the word periods off to the side, in parentheses, you put energy levels, energy shells, so that's the rings, right, where the electrons came out. How many electrons fill up the first energy level?
2.
2. How many fill up the second? 8. And when you go to draw the third, they can hold up to 18. What I want you to do, what I want you to add is like what I did on that periodic table there.
18, huh?
Period 1 has how many energy levels? 1, to draw one circle around the number 1. How many energy levels is in period 2? 2, to draw 2 circles around period, then that number 2. Around the number 3, draw 3 circles. And we'll stop there because I know it gets less and less every time you go down. But visually, you get the idea. So it's like what I did on that periodic table there. I'll circle around 1, 2 circles around 2, 3 circles around 3.
Just having this little breakdown in front of you. Now, we're going to move down to the bottom of the periodic table. We're going to talk about reactivity real quick. I'm going to draw a big long arrow going from right to left, and I'm going to label it increasing reactivity. So as the arrow moves toward the left, or as the groups move toward the left, they get more reactive. So we're just going to write increasing activity down towards the bottom. The most reactive group or family on the periodic table is group 1. So I'm going to just put a little most reactive down there, just so I know that those are highly reactive. They have one valence electron, and they want to give that thing away as fast as possible. They react very violently with a lot of different other elements.
Okay. So do what he says there with the arrow, increasing reactivity, most reactive. I don't love that part because there's something that is incorrect about it. So group 1 is one of the most reactive groups on the periodic table, but who else is one of the most reactive?
7.
But 17, right? Because they have 7 valence electrons.
Yeah.
So under group 17, which is over here, second to last group, put most reactive under here. So you see that group 17 is also one of the most reactive. Group 1 and 17 are the most reactive groups on this periodic table.
The fog is here. The fog is here. The fog is here.
Now, going back to the other side, group 18, these are the most stable. So I'm going to write most stable down here. And this group has a special name. It's called...
Okay, most stable is talking about group 18. What's another name? What does that mean? If they're stable, are they reactive or not reactive?
Non-reactive.
Not reactive. So next to most stable, put not reactive. Or non-reactive, but not reactive.
noble gases. So just right underneath the element radon, I'm just going to write noble gases, just in case that happens to pop up. So these guys are real stable. They're not giving any electrons away. Their electron shells are totally full. All right, so the periodic table is totally marked up. Now we want to go back to the top of the periodic table, and we're going to start talking about different other chemistry principles. So I'm going to focus in on this top left corner, and we're going to first talk about a compound known as glucose, which is C6H12O6. We're going to make some comments about that real quick. Seen this before, show up on previous star tests. So 3 elements. It has 3 elements. We do that by counting the capital letters: carbon, hydrogen, and oxygen. And it has a total of 24 atoms. We do that by counting the subscripts. That's the little number behind each of the particular elements. If there is not a number there, then it's implied that it is 1 atom. You cannot have a letter and not have an atom, so it has to be a 1. In this case, it is 24.
Okay, so C6H12O6, there's 3 elements. Remember, for an element on the periodic table, if it's a capital, lowercase, 1 element. It's capital, capital next to each other, that's 2 different elements. Like if the C and the H were next to each other, both capitals, that tells us it's 2 different elements. Small numbers next to the symbols are called what?
Exponents?
Wait, the symbols?
No, but it starts with an S.
Subscripts. Yes. Snake.
That tells us how many of that element we have. If there's a big number in front, what is that called? Do you remember? Starts with C. Coefficient. Coefficient. If there's like a big 2 here, that's called a coefficient. What do you do to that big 2 to all of this? Multiply it. Perfect. On these questions, remember, just be careful to see if it's asking for you to how many elements total, how many elements for a certain, or how many atoms for a certain element. You got to see what it's asking.
All right, the next thing you know about chemistry is the RAP acronym that we created. And this is talking about balanced and unbalanced equations. On each side of the arrow, there are reactants on the left and products on the right. In order to be balanced, they have to have the same number on each side, the same number of atoms. We call this RAP because there's an R in reactant, the A stands for the arrow, and the P stands for the product. So totally balanced and those don't totally match up. Okay, now let's go to the subatomic particles. We're going to be talking about protons, neutrons, and electrons. First, we're going to talk about protons. Protons, and we're going to list the charge, which is positive. They are found inside the nucleus. Zoom this in a little bit more so you can see it. And then next we have a neutron, which is a
Yes,
negative
protons
charge,
plus
excuse me,
inside.
no charge, or a neutral charge, and they are found inside the atom as well. And then the electron, which is negative, and found outside the nucleus. Also want to make note of the
So we put protons are have a positive charge, are inside, meaning inside the nucleus. Neutron, no charge, inside the nucleus as well. Electrons, negative, are the only ones that are
top
outside.
two, the protons and the neutrons, make up the most mass of the atom. This is where all the mass is found in the atom.
Most mass
Electrons have a tiny, tiny little bit of mass.
from the nucleus. Most of the mass of the atom comes from protons and neutrons. Remember, electrons are super tiny. We act like they don't contribute to the mass of these, but it's just super tiny.
Mass, but not that much. Most of the mass comes from the protons and the neutrons. And as we move to the top right corner of the sheet, we're going to now talk about metals, metalloids, and nonmetals. So
Metals.
we're calling those on the left side of the periodic table. So basically, anything to the left of the staircase on the periodic table, we're saying is a metal. And they have similar properties. They are shiny luster. That means they're
Calcium's a
shiny.
metal?
That's the way the light reflects off them. And then they are malleable, which means they can be pounded into sheets. They are also good conductors. And they are poor insulators. You could also mention that they are ductile as well, which means they can be pulled into a wire, like you see in copper wire, on your electricity.
Okay, so we put metals, left side. They're shiny, which means they have luster. Malleable, which means bendable. Good conductors of heat and electricity. They are poor insulators.
Hydrogen's a metal.
No, on hydrogen's the only one on the left side that's non-metal.
Oh, okay.
All right, next
Well,
we'll
that
talk
explains
about metalloids.
nothing.
And metalloids are found usually touching the staircase on the periodic table. So they're touching that black line that looks like a staircase on the periodic table. And all those are metalloids except for one, which is aluminum. And that's just
So box out aluminum,
Aluminum.
circle aluminum right here, and off to the side draw an arrow or a little point that says metal. So you know that aluminum is a metal. Even though it touches the stair step line, it's the only one that's a metal. Number 13.
Don't you mean,
You guys are ready, yeah. We just need that real quick. I paused it.
Miss, don't you mean aluminium?
when you have
Okay.
is a metal. When you think of aluminum, it does look like it has lots of properties of metal, so you want to make sure that you know that that is actually a metal, just in case that pops up. All right, so metalloids they have properties of both. I'm not going to list all the properties here, we just need to know they have properties of both. They could be shiny and they could
Properties
be
of both.
so.
Like bismuth.
And then lastly, we have
Bismuth isn't a metal.
nonmetals are on the right side of the periodic table, generally not generally, they are to the right of the staircase. And they are mostly gas. There are some exceptions to that, just like in everything in science. And they are dull, meaning they have no shine to them. Kind of think of chalk when you think of dull, even though chalk is not an element, it has a dull texture. They are good insulators. And they are poor conductors.
Silica.
Alright, so this is the periodic table.
Okay, so it says non-metals. I know he zooms out, so it's hard to see it. Mainly on the right side. Who's on the left side that's a non-metal? Because on the left side, it's a non-metal. Hydrogen, they're mostly gases, don't like chalk. Chalk is just a good visual to represent non-metals.
I like chalk.
Good insulators and
Tastes
poor
yummy.
conductors, so it's typically the opposite of what metals are.
You see, it didn't really take that long.
Okay,
That's it.
we're gonna add more to this right now, so. There's a couple things, it's not a ton, it's stuff I'm gonna tell you, so listen to what I'm saying and write it down. Now, I know that some of you have maybe larger handwriting than this guy and how it's set up, some is smaller, so make this work wherever you have space. So one of the first things I want you to write on here is schnapps.
Schnapps.
CHNOPS.
Like-
Remember, that is the symbols for organic compounds. So put organic schnapps equals organic compounds equals schnapps. CHNOPS, that's carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Carbon has to be in your answer. So after you write compounds equals schnapps or schnapps equals organic compounds, underline the C in schnapps because carbon has to be in your answer. It has to. Tuesday. Okay, next thing I want you to do is next is sulfur. So sulfur's over here in group 16, that's circled, capital S. Okay? So
Highly
circle-
toxic.
Circle that element card, draw an arrow off to the side. And put, it's yellow, it's a non-metal, and it smells like eggs.
Isn't it like toxic?
It's not that it's toxic, it's
I thought we
just,
wrote this before.
it is,
Didn't we use it in a bomb?
I thought we used it.
it's not what it's, by itself, it's not, but it's used with other stuff, and mixed stuff, it can be. Okay, so sulfur, circle it off the side, put non-metal, yellow, smells like eggs. And then the last, one of the last things I want, there's two, this one and one more, but wherever you have room, put the word chemical change, and put that that's when something changes into something new. Gotta write this down, okay?
Yeah, man. Isn't schnapps from like Star Wars? What aren't you yapping about?
And then what I would recommend is over here where you put valence electrons in the space, if you have room there, put 2818, because that's the number of electrons that belong to each shell, right? 2 on the first one, the full 8 on the second,